A company builds cylinders. Its model A cylinder has radius r equals 10 and height h equals 16. What is the volume in centimeters cubed of model A? All right, so we've been given this formula, which is helpful, of course, pi r squared times height. So for model A, our r is 10 and our height is 16. So that's pretty much all they want you to do there. Plug those numbers in. When you do, you get 1600 pi of the volume. And this is in centimeters cubed. The model also builds, the company also builds model B, and that has a radius of 8. Each model B has the same volume as model A. What is the height of model B? So a little bit different this time. This time they're telling you that the volume is the same as model A, which we had just calculated as 1,600 pi. Now their formula is again the same as here, pi r squared height. Now the radius they have given me is h, and the height is what they have not given, and that's what we have to calculate. So the pi's cancel, so you just get 1600 is 64h, and when you divide through by 64, you get h equal to 25. So this is referring to the height in centimeters of model B. The company makes a rectangular box called box A that holds 6 model A cylinders. The cylinders are placed into the box vertically and tightly packed as shown. Determine the volume in centimeters cubed of box A. So the volume of this box will be length times width times height. Now this is the height from here to there, and that height is going to be the same as the height of the cylinder. And the cylinder that's called model A, I believe, has a height of 16. Okay, so that part we know. So let me just squeeze in that 16 right there. Okay, so the length and width is what we have to talk about. So let me just draw a bird's eye view of, and I'm going to try. I don't think I'll be very accurate here, but you guys sort of get the point. It's supposed to be touching, and I'm trying to touch them. Okay, so that's basically what it looks like. And from here to here will be the length, and from here to here will be the width. Well, from there to there is the length, but if you look at it, it's 3 circles, the diameter of 3 circles, so that's basically 6r. So that 6r goes here. And in a very similar way, if you look at the width, that's the diameter of 2 circles, which is 4r. So there we go. And I guess we just have to calculate that now. So that is 24r squared times 16. And r, what is r in this case? The model A, right? So model A, the radius was 10. Okay, so there we go. So that's going to be 24 times 10 squared times 16. And when you do that math, you get 38400. And part D, the company makes another rectangular box called box B that holds 6 model B cylinders. The cylinders are placed into the box vertically and tightly packed, just as was shown in part C. State whether the volume of box B is less than, greater than, or equal. Okay, so this time it's the same story. I guess we could just use that same diagram, but the only difference is now instead of model A up here, now we have model B cylinders. Okay, so the volume of this would be pretty much the same, length times width times height, but the numbers will be different slightly. The height of the model B, I think we had calculated that earlier. Where did we calculate that? Somewhere, right? Oh, here it is. The height was 25. Okay, so we put that here. And then from this diagram, the length and width are going to be the same in terms of their relationship to the radius. So the length is, again, 6r, and the width is 4r. So this now becomes 24r squared times 25, like that. And then the radius of model B, I think that was also given to us. Here it is. Model B radius is 8. So plug that in there. So 24 times 8 squared times 25, and then when you do this math, it's 38,400. So same. So that means that the volume of A, or box A, I should say, box A is the same as the volume of box B. And that's pretty much all they're saying, all they're asking. Is it less than, greater than, or equal to? And the answer is it's equal to. In Canada, a quarter is worth 25 cents, a dime is worth 10 cents, and a nickel is worth 5 cents. Susan has 3 quarters, 18 dimes, and 25 nickels. What is the total value of Susan's coins? So 3 times 25 cents, and we have 18 of these dimes, so that's 10 cents. And then we have 25 of these nickels. And when you do this math, it comes out to $3.80. Alan has equal number of dimes and nickels and no other coins. His coins have a total value of $1.50. How many nickels does Alan have? So in Alan's case, dimes is equal to nickels. So if we were to calculate it, it's 0.1 times dimes plus 0.05 times nickels, and that is equal to 1.50. But since d is equal to n, we can just substitute that in here. So it'll be 0.1d plus 0.05d is equal to 1.50. And then when we add these guys, it just becomes 1.15d is equal to 1.50. And then we divide through and by 1.15, and you'd get d is equal to 10. So that means n is equal to 10. And I think that's what they're asking. How many nickels? He has 10 nickels. Elise has $10.65 in quarters and dimes. If Elise has x quarters and 2x plus 3 dimes, what is the value of x? So 10.65 is equal to x quarters. So each quarter has a value of 0.25. And how many dimes? 2x plus 3 dimes, and each dime has a value of 0.1. So that's pretty much the equation. So let's expand this. So 0.25x plus 0.2x plus 0.3, right? So that's going to be 0.45x plus 0.3, 10.65, right? And then I guess we just bring this over, so this becomes 10.35 is 0.45x, and then divide through by 0.45, and you will get 23. So x equals 23, and yeah, that's what they wanted. A formula for the sum of the first n positive integers is 1 plus 2 plus 3 plus ... plus n is equal to n times n plus 1 over 2. For example, to calculate the sum of the first 4 positive integers, we evaluate 1 plus 2 plus 3 plus 4 is equal to 4 times 4 plus 1 all over 2, which is 10. What is the sum of the first 200 positive integers? So using that formula, n times n plus 1 all over 2, n in this case is 200, so it's going to be 200 times 201 all over 2, and that calculates to 20100. So pretty cool formula, right? Calculate the sum of the first, the 50 consecutive integers beginning at 151. That is 151 plus 152, ... all the way up to 200. Okay. So this is a bit different, right? Because we're not starting with 1 plus 2 this time. We're starting with 151. So how do we do that? Well, you look at it as follows. Look at 1 plus 2 plus 3 plus ... all the way up to 200, right? And then subtract from that 1 plus 2 plus 3 plus all the way up to 150. If you do that, you will get this guy, which is 151 plus all the way up to 200. So that's pretty much how you do this. Now, this guy here, that's easy. I think we just did that. It'd be 200 times 201 divided by 2. And then this guy here is 150 times 151 all over 200. So if I were to do that math, It's 20100 minus 11325, and that is 8775. So the interesting way of using that formula to calculate that sum. And part C says, starting with the sum of the first 1,000 positive integers, every third integer is removed to create a new sum. Calculate this new sum. So this is a bit different, but don't get intimidated. It's actually pretty straightforward. So the first thing I'm going to do is just calculate the entire sum up here, which is 1 plus 2 plus 3 all the way to 1,000. So that's pretty easy. 1 plus 2 plus 3 all the way up to 1,000. We just use our formula, so it's going to be 1,000 times 1,001, all divided by 2, and that is 500500. Okay, great. But that's not what they're asking. They're asking this sum. And what this is basically the whole thing, 1 plus 2 plus 3, all the way up to 1,000, right? But subtracting from it every third integer. So you're subtracting 3, and then I believe 6 is gone, and then 9 is gone, and so on, all the way up to, looks like 999 is the last one that they remove. So that's basically, let's put in a plus sign in there. Okay, so that's the essence of this. Okay, not a problem. This part here we just did, that's 500. But this part here, how do we do that? Well, the easiest way is just to factor out a 3, and when you do, you get 1 plus 2 plus 3, all the way up till 333, I believe. And then that, of course, you know how to do. So let's just put this in here. That one was going to be 333 times 334 all over 2. And then when we crunch out these numbers, let's see here. This is going to be 166833, and then if you subtract it, it becomes 333667. So there you go. That's the answer to the sum of that set of numbers. The token dot is placed on a hexagonal grid. As shown at each step, the token can be moved to an adjacent hexagon in one of the 3 directions, either going to the northwest, northeast, or just the north. The token can never be moved in any of the directions that go south, I guess. What is the minimum number of steps required to get the token to the hexagon labeled A? All right, so here is the starting position, and here is the ending position, and they want you to figure out the minimum. So you fiddle around with this, and I guess just concentrating on the fact that you can only do these moves. And let's see here. I guess, let me see. If I go 1, 2, 3, 4, 5, 6, 7, 8, that's absolute direct, right? As you guys remember, if you have 2 points, the shortest distance between 2 points is a straight line. Now I can't, of course, go straight line from those 2 points, but I can go the way I did, which is in keeping consistent with those moves. I can go straight to there, and then I can just go straight up. And when I do that, I have gone 1, 2, 3, 4, 5, 6, 7, 8. And you'll find that the 8 is indeed the minimum. You can't go to A in 7 or less. With justification, determine the maximum number of steps that be taken to end in A. So now they want max. So they want you to, again, keeping consistent with those moves, see how you can get to A with the maximum. Now what you do is you kind of stretch it out a little bit. Is you start here, and then you go all the way up here, and then you can go to there, and that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that 11 is the maximum. And you can experiment with other ways to see if you can get more than 11, but you won't be able to. So you have to, of course, sort of justify that, and you can use the fact that these can never be utilized in the moves, so you're kind of limited as to where you can go for example, once you get to here, you can only go to this guy, because if you went up here, then you can only go here, and then you're stuck here because you can't go back down. So like that, you just have to explain it in words. I just sort of did it very quickly.